Welcome to Learn Object-Oriented PHP with myself, Gary Clark, and in this first recording I'm going to get us off to a good start by answering the questions: what are objects and how do we create them? The easiest way for me to explain to you what objects are is to simply show you. The good news is you're already familiar with thousands of objects because there are visual representations of them all over the applications, websites, software that you use every day. In the simplest explanation, they're basically the things that make up an application. Let's have a look at an example and I'll show you what I mean by that. So I'm only going to use examples which you might be familiar with. Here's Amazon. This is my Amazon account. I'm able to sign into my Amazon account because I'm a customer, and a customer is an object. Up in the top right hand corner there you'll see my basket. A basket is also an object. Here's some products. Products are also objects. They are the representations of things, or rather I should say they are the data representation of things. And the beauty of object-oriented programming is that we can take these objects and we can give them characteristics and also the ability to do things. So as you can see there, it's displaying my name. The products all have names and they all have prices. As a customer, which is an object, I can select a product and place it in a basket. These names, these characteristics and these pieces of functionality are all associated with the object and they all live with the object. In this first recording we're going to replicate a fairly well-known type of object, and that is a Twitter user. So here is my Twitter profile, and as you can see there's various pieces of data there. It's got name, username, location, etc. In PHP, or in object-oriented PHP, we refer to these pieces of data as properties or class properties. In other object-oriented programming languages, they're often referred to as attributes. You can interchange the two, they both mean the same thing. So as you can see here, our properties are name, username, bio, location and join date. So that's enough talking. This course is more about doing, so follow along with me. I've created a folder called OOPHP in my editor. Inside of that I've created a folder called chapter 1, and inside of that I'm creating a new PHP file called creating-objects. I'm using PHP Storm, so as you can see my opening PHP tag has been done for me. Use whichever editor you want. I'm not using any of the fancy features, I'm literally just going to be using this as a code editor. So how do we create objects? Where do they come from? In order to create objects we need something called a class, and a class, if you like, is a blueprint, a mold. It's a specification which tells us what characteristics and what functionality our objects should have. A class is created like this. We have the class keyword followed by the name of the class, in our case a user, and you uppercase the first letter and then you follow that with opening and closing curly braces. Then you need to define whatever properties your class should have. The way you do that is you put a visibility keyword, which can be public, protected or private, followed by a variable name. So in our case we're going to have name, we're going to have a username, I think we'll have a follow account just to give us a slight variation from using strings. Don't get too hung up on the visibility keywords public, protected and private for the time being. At the moment we're just going to use public because that's the least restrictive. Now let's create an object from this class. As you can see, I'm outside of the class's curly braces. Now typically you won't actually create an object in the same file as your class files, but this is just for demonstration purposes, and so I've created a variable called Gary object, and then I'm making an assignment. So I use the new keyword which is used for creating objects from classes. I specify the class name, user, and then opening and closing parentheses, which in this case are optional, but we'll not get into that in too much detail. And this creates a user object which I assign to the Gary object variable. This action can be referred to as creating an object or instantiating a class, because we're creating an instance of that class. Let's examine this newly created object, and we can do that using the print_r function, which allows us to print out the object in a human readable way. So I'm moving into the chapter 1 folder of my project folder, and I'm going to start up PHP's local server. You can do this using PHP-S localhost : and then any port number. I usually choose 8000 or 8080. So I'll copy that, I'll go over to the browser, and I just paste in that and append creating objects.php onto the end of it because that's the name of our file. So here we go, it says we have a user object and then it lists out our properties. So we're getting somewhere, but that's not very helpful because we didn't give our properties any values. I think if we go back to the code, give our properties some values and then come back, then it'll be a bit more meaningful. So let me show you how to assign values to properties, and we use this thing here. It's called the object operator. It's basically a hyphen and a right bracket. We follow that with the property variable, and you'll notice that we drop the $sign off the beginning of that. And then the way we assign this is the way we assign any variable. We use the equal sign and then just the value. So we'll do that for name, username, and for our follower count. Once we round off this last one, then we do the same as what we did before. Using the print_r function, we just print out that object in a human readable fashion, and then let's go back to the browser and give it a refresh and see what we come up with. And so there you go. Now it's saying we have a user object. The name property is Gary Clark. The username property has a value of Gary Clark Tech, and the follower count has a value of 50. Now it's over to you to get your hands dirty and give this a go yourself. Here's a reminder of the steps. So I want you to instantiate a new user object, name the variable after yourself, set the name, username, and follower count properties, and then use a print_r function to check that you've created it correctly and check your work in the browser. So give it a go. Here's my solution. So say for example your name was John Smith. This is how we would have done it. So John object equals new user and opening and closing parentheses, and then same as we did for my name, username, and follower count, we just assign these properties. We do that in the same way that we assign any value to a variable. We use the assignment operator, otherwise known as the equal sign, and then all we're doing here is we're just going to print that out over to the browser, and there you go. So the name has a value of John Smith, username has a value of @John Smith, and the follower count is 1000. In the previous recording, we had a look at what objects are, and we established that objects could hold pieces of data which were referred to as properties. In this one, we're going to have a look at object functionality. When you add functions to an object, we call them methods, and that's what we're going to do in this recording. So I'm in exactly the same folder as where I left off in the previous recording, but I've created a new PHP file called defining methods, and for now just create opening PHP tags. Then we're going to go back to Amazon and have a look at another object. So I've just added this item to the basket and clicking proceed to checkout, and here is the basket. So we've got two properties that we're going to examine, items, and there's a cost, so we're going to call it item cost or something like that, and postage and packing, which we'll probably end up calling shipping cost or something like that. So what I want you to do now is this: create a basket class, add an items total and shipping cost public properties, instantiate a basket using the new keyword. Instantiate just means create a basket, and instantiate, it's saying that you're creating an instance of a basket. Set values for both properties, and then just file dump your work and go and check it out in the browser. Just like before, I recommend that you do all the practical exercises that I set you. This is how you learn. Here's my solution. So I'm creating a basket using the word class, and then basket with an uppercase B, opening and closing curly braces. What I'll show you here is that the opening brace can go on the next line, and that is the modern convention, which you'll probably see more these days. Next, what I'm going to do is I'm going to create the properties. So two public properties, one called items total, and I'll use camel case to do that, but don't get too hung up on conventions and things like that at this stage in your development. Shipping cost, and so all we need to do now is instantiate a basket and set some properties. So it's basket equals new basket, and we just set our properties like so, which hopefully you should have remembered from the previous recording. Basket, right arrow, items total equals, and let's just set any numerical value for that. And you do exactly the same thing for shipping cost. So basket, right arrow, also known as object operator, shipping cost equals 10. And then all we're going to do is just dump that out and make sure that those values have been set. So var underscore dump, and we'll just look at the whole basket. Remember, we're going to change our URL, so it's localhost defining methods.php, and there you have it. So we have an object. That object is a basket and has an items total of 50 and a shipping cost of 10. Hopefully that stuff should be sinking in now. The purpose of that exercise was really to get us up to this point where we are now. So we have a basket, has a couple of properties. What I want to do now is give the basket the functionality to calculate a subtotal using these properties. And the way I do that is I add a public function. So like we gave our properties the public keyword, you do exactly the same thing with your methods, which quite confusingly are called function. So even though we refer to them as methods, we create them just like we do with other functions by using the function word, and we're going to call this calculate subtotal. In order to access an object's properties from within an object's methods, we use the this keyword, which is a $sign followed by the word this, and what this refers to is the actual class itself. So you're saying this basket, and then you use the object operator like we did to access the properties from outside the class, and then we just access the properties like we did before. So this items total plus this shipping cost will give us the subtotal which we're looking for. Now I'll show you how you call that method using the object. So I'll just create a little bit of space for myself here, and you do it in exactly the same way as how you access a property. So we say basket, right arrow, and then calculate subtotal. What do you think will happen if we check that out in the browser now? Let's have a quick look. Blank screen, because we haven't actually returned a value from the method. So in order to do that, I'm going to store the sum of these two values in a variable called subtotal, and then all I need to do is drop down a line and just return that subtotal, and then that will make this method a lot more useful to us. And we can view the output of that by just var dumping basket calculate subtotal. And so if you see, we've got an items total of 50 and a shipping cost of 10, so hopefully we should see a value of 60 when we go back to the browser and refresh. And there you go, so far so good. And of course what is more common is that you would store the actual returned value in another variable. So we'll do that now. Subtotal equals basket calculate subtotal, and we'll just var dump that and have a look at that just to make sure, or just to prove that that is how this works. And we'll just go back to the browser, quick refresh, everything's still the same there. Now it's your turn. What we need to do is add a public discount property and then rewrite this line so that the discount is deducted. Set a discount value of 30. Then all you need to do is var dump the subtotal and go to the browser and check that you've got the correct value. You should get a value of 30. So here's my solution. Public discount. It's just really basic maths. You just minus the discount from this. So it's this, right arrow, discount, because you're accessing an object property from within a method. I'm just deleting the comments as we go along just to remove a bit of noise from the code. And then we set a discount value of 30. This should be all very straightforward to you by now. So 50 plus 10 minus 30 should equal 30. Let's go back to the browser and refresh. And there you go, 30. So how did you get on with that? And are you enjoying object-oriented PHP so far? Hopefully things are starting to make sense to you and it's all starting to fit into place. In the next recording, what we're going to do is we're going to have a look at Spotify, and we're going to start making objects interact with each other by taking a song object and adding it to a playlist object. We're finally going to start taking a look at object interaction, and it's the interaction between objects which really started to make object-oriented programming click for me. It all suddenly made sense, and what I'd done up to that point just seems so unnecessarily complicated. Hopefully I'm going to demonstrate that to you. I'm going to take a real-world application and use a real-world example of objects interacting with each other. I think you're going to really enjoy this one, and hopefully this is where this stuff will really start to click for you. Let's get things started by creating a new file for this section, which I'll call Object Interaction, and I'm in the same folder as what I did for the first two recordings, chapter 1, and I'll just start by doing my opening PHP tags, but nothing further, and we'll go and have a look at what we're going to do. So here's Spotify. This is my brother's rock playlist, and guess what? Our playlist is an object. Just take a second to see what properties that playlist object might have, and do you see any other objects on the page? I'm scrolling down through my brother's playlist and I've noticed that there are no Octopus theme songs on here, so I'm going to go over to the Beatles classic Abbey Road. I'm going to take a song object, Octopus's Garden, and I'm just going to drag that and add it to my brother's rock playlist, and he'll be absolutely delighted with that. And in this recording what we're going to do is recreate what I just did. We're going to take a song object and add it to a playlist object. So first off, we need to create a song class, create song ID and title public properties, instantiate an Octopus's Garden song using the new keyword, and then check in the browser. So here's my solution. If you'd rather pause it and have a go at it yourself first, then by all means do that. What I would preach is practice, 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 so that would be an excellent idea. Very simple one to do this, so we just create a class with a public property called song ID and a public property called title. So internally Spotify will have a song ID for each song, will have a unique identifier, and so that's what I mean by that, and for this we'll just use a numerical value. So in order to create our song object, I'm just going to create a variable called Octopus Song. Then I do equals new song opening and closing parentheses. I just need to set the two properties. I do that by saying Octopus Song right arrow property 1, Octopus Song right arrow property 2, which are song ID and title respectively. So I'll just create a song ID of 1, and obviously the title is Octopus's Garden. So I'll use double quotes because there's a single quote in the title. Great stuff. So we just need to var dump that and then go and check our browser. Remember, we've created a new file, so we need to give it the new file name, which is objectinteraction.php, if you've got your server set up the same way as what I have. And so there you go, we have an object. Object is a song ID of 1 and the title of Octopus's Garden. So hopefully you should have found that fairly straightforward by now. What I want to do next is go back to Spotify and just take another look at the playlist object and try and pick out some properties. So here we have one. The playlist has a name. What others can you see? Because here's quite a big one. The playlist has songs. And we call this composition because we've already said that a song is an object. We've said that a playlist is an object. And now we're saying that we can add a song object to a playlist object. And if you think about that and the opportunities it presents us, this is huge. Let's create a playlist now. So I'll give it a couple of public properties, and the first one will be name and the second one will be songs, plural. No one said that properties had to be singular, so I'm going to give it a name of songs, and I'm also going to set it to an empty array, and that is really just to demonstrate an intention. This is what I expect songs to be. So we'll go into setting default values and type hinting and stuff like that later on, but for now this is just to say this is what I expect the songs property to be, an array. So I'll create a new playlist, playlist equals new playlist, and I'm just going to dump out the songs property on the playlist object just to demonstrate what happens when you set a property to an empty array. So I'll comment out the octopus song var dump so we don't see that. Refresh, and so as you can see, our playlist songs property starts off as an empty array. The 0 means it has no length, there are no items inside it. But let's change that now. I'm going to create a method which will take a song and add it to the songs array. So public function add song. Always use descriptive names, don't just put something like add. Add what? Make sure another developer could read this and know exactly what's going on. And so in order to add a song to the songs array, first things first, we're actually going to need a song. So we'll pass a song in to the method as an argument, and that will be a song object. And then in order to add it to the songs array, we say this, as in this keyword, this songs opening and closing brackets. So adding an element to an array inside a method is just the same as adding it to any other array variable. That's all we need to do with that method. We're not returning any value, all we're doing is adding the song to an array. So let's give our playlist some properties. First of all, we'll give it a name, and we just called it rock. And then we're going to call our add song method. So playlist, right arrow to call a method, add song. Then we need to go and get a song object. So I'll copy this octopus song variable here. I'll pass that in. And that's it. That should be all we need to do in order to add a song to the playlist. Right, shall we go and have a look what we've got? So I'm going to dump out the playlist object, and we'll take a look at the entire thing and see what we've got. So var dump playlist, over to the browser. Okay, so quite a bit of information on the screen there, but just glancing I see that we have an object which is a playlist. It has a name property and a songs property which is an array. It's a bit messy, so what we'll do is we'll actually go back and we shall just dump out the songs property so we can have a closer look at that. So var dump playlist, right arrow, songs, back to the browser for a refresh. And there we go, we have an array with one item which is a song object, song ID 1, title is Octopus's Garden. Perfect. Now it's your turn. Instantiate a song object, set a song ID and title, and then add the song to the rock playlist. Think you can do that? I'm pretty sure you can by now. I'd encourage you to always do the practicals. I know I say this and I'm like a stuck record, but it really will help. Here's my solution. So I'm going to stay with an underwater theme. Yellow submarine equals new song. Then what I need to do is set a song ID and title. So yellow submarine, right arrow, song ID. I'll just give it number 2 because I call it Octopus's Garden number 1. Title equals yellow submarine. And then in order to add it to the playlist, it's just playlist, right arrow, add song, and then you pass in the yellow submarine. When I refresh the browser now, I can see that my songs property, or the songs array, has grown. It's got an extra item in there now, which is also an object, and that object is a song. So I'll put it down on its own line. Hopefully that makes it a little easier for you to read. So we have an object which is a song, has a song ID of 2, and the title is Yellow Submarine. Hopefully you got the same as me. If you got a different result, or if you got any errors, make sure you go back and check your code against mine. And don't be too worried about making errors. Making errors is really how you learn this stuff. You need to make hundreds and hundreds of errors before you can do this stuff professionally. So the more errors you get out of your system now, the better that is, believe it or not. So that brings us to the end of this recording. We've covered quite a bit of ground there. We've done some object interaction as well as learning about composition, i.e. setting objects as properties on other objects, in addition to stuff that you should already be getting quite comfortable now, such as adding arguments to methods and using this keyword, etc. So you're making good progress, my friend. Let's keep this momentum going in the next one, where we'll level things up once again. In this recording, we're going to look at a special method called the constructor. And what I've decided to do from this point forward is to keep the classes and the logic separate in separate files, which is good programming practice. So I've created a chapter 2 folder, which is inside the OO.php folder, and in there I've started out by creating a constructors PHP file. So if you get yourself up to this point, all I'm going to do to start off is create an empty web page. So if you're using Visual Studio Code like me, you can just do exclamation mark and then tab, and it'll produce an empty HTML page. Otherwise, just do an opening and closing HTML tags and also body tags, and inside there I've got opening and closing PHP tags. Anyway, this is the example I'm going to use for this particular one. This is the discussion tab on my YouTube page. As you can see, it's made up of comments which have various properties such as text, and you have a user, you have a date or time when it was posted, various little things such as thumbs up, like, thumbs down. I'm going to base my initial work around this text property, as that is what you could say is the primary property for a comment. And so in the same folder, the chapter 2 folder, I'm now going to create a comment class, and this will be dedicated just to holding the comment class and its properties, methods, etc., and no other PHP code will go in there. So comment PHP, we need our opening PHP tags, and we've created classes before. All you need to do is use the class keyword, then comment, opening and closing braces, then we'll add that text property, and after that we'll add a constructor method. So what is one of those? Here's a description from someone that I learnt from. You'll use constructors to do whatever should always be done, and done first when an object of this class is made. So what we're saying is that whenever you say new comment, then the constructor method will be called, and whatever code is inside that constructor method will be executed. The way we create a constructor is like this: 2 underscores, so underscore construct, open and closing brackets, and then the rest of it is just like any other method. And we call a constructor a magic method, so it's one of a series of special PHP methods. And what I'm doing here is setting the text property of the comment. So thinking of the description I've just shown you, whatever should be done and done first. I think it's fair to say that a comment will always need some text, so that should always be done. Whether it should be done first is arguable, but this is a pretty good use case and a fairly realistic one. So we pass in text into the constructor, and then we set that property using that variable. And this is easily the most common usage of constructors that you'll see, i.e. setting properties on objects. Occasionally you'll call other methods, but setting properties is your main one. Let's now go over to constructors PHP, and this is where we're going to add our logic. So first we need to pull in the comment class, and we do that by requiring the comment PHP file. And then what we're going to do is create a comment. So comment equals new comment. And if you recall from our previous objects that we created, we've got these opening and closing parentheses, and you've probably wondered what they're for. So this is where we actually pass in our constructor arguments. So if we didn't have any constructor arguments, we wouldn't actually need these parentheses, but it's quite a common practice to include them anyway, even if they're empty. So what we're going to do here is pass in our comment text. So just make up anything. This is some comment text will do. Then all we're going to do to demonstrate this is just echo out the text property on our newly created comment object. So echo comment right arrow text. Then I'm going to go and make sure that my server's running. So if you're doing the same as me, I'm going to move from the OO.php folder into the chapter 2 folder, and then I'm going to start up my PHP's built-in server. And you can copy the command that you see on the screen, which is php -S localhost :8000, which I'll copy and paste in, followed by / constructors.php. And there we go. So there's our echoed text. I'll bump it up so you can see it. This is some comment text. So far so good. Now it's your turn to have a little go. Obviously there'll need to be some way of connecting the comment to a user, and the way we're going to do that is by having a user ID attribute, which will be numeric. An attribute just means the same thing as property. It can also be called class variable. So we'll add the user ID to the comment constructor as a second parameter, and then when we instantiate the comment we need to include the user ID when we pass it into the opening and closing parentheses. Then we just need to remove the echo statement, and I want you to add a paragraph where you echo out the text and the user ID, and then go and check your work in the browser. So here's my solution. I'd encourage you to give it a go, but here's what you need to do. So I've took my comments and I've pasted them because I like to keep track of what I'm doing. First we need to create a public property for the user ID. I'll delete my comments as I go along, my instructions. Then you pass that into the constructor as the second parameter, and obviously you need to set the user ID property to that variable. All very straightforward, and you'll do this stuff day in, day out. A lot of the times it doesn't get any more complicated than this. So this user ID equals user ID. Again, we'll clean up our comments, and now we just need to go over to the constructors PHP file, which is where we add our logic. And all we're saying here is that we want to remove the echo statement and actually create a paragraph in the HTML. So we'll add our second argument, so we're just going to give it a user ID of 10. So you pass that into the parentheses as the second param there, and then we're going to move outside of the opening and closing PHP tags and create a paragraph. And so I'm echoing out the comment text. Then I want to use our new user ID property, so, and then same again here, I'm just going to echo that out. So comment, right arrow, user ID. That's all we need to do. Back to the browser, give that a refresh. This is some comment text by 10. So we'll change that to by a user 10. Give that a refresh. Excellent. So just a quick recap in case that went a bit fast. So comment text, the text was passed into our comment constructor as the first argument. Then we said by user, and then we echoed out comment user ID, and the user ID was passed in as the second argument. And so like I said about constructors, they are used to do whatever should be done and done first. So it's fair to say that you'll always need to say who owns the comment, i.e. who created the comment, and a comment will always need some text. So this is a very good example of a constructor's usage. In the next one, I'm going to introduce inheritance, which is a vital concept in object-oriented programming, and it's one of the things that makes it so effective. One of the ways in which objects make programming more efficient is the ability to use one class as the basis for other classes. In other words, our objects and classes can inherit from parents, inherit attributes from parents in the same way that humans can inherit attributes from parents. Those attributes, as far as we're concerned in object-oriented programming, we've already seen them. They are properties and methods. That's what we're going to look at in this recording. We're going to take this account class and extend it with child classes which inherit its properties and methods. So here is our account class again, and we are going to extend it with a checking account. As you can see, the checking account inherits all the base properties and methods without us having to explicitly declare them when we actually create the class. But not only that, the checking account can then declare its own properties and methods. For example, it can have a transfer method, which might be something which is unique to a checking account. Other accounts might not have this functionality. So by doing this, we're saying that it will inherit all the base features of the parent, but it can also have little characteristics, properties and methods which also make it unique. So let's make a start. I'm in the chapter 2 folder and I'm creating a class which will be account.php, and I'm just going to add those properties and methods which we saw on the diagram, and these will be available to all the classes which inherit from this account. So we'll have a public property called account number, we'll have a public property called balance, and then we need to add our 3 methods. So we're not going to add full functionality to our methods, we're just going to echo stuff out just to illustrate what is actually happening. So for the deposit, we'll pass an argument of amount, and then what we'll do is we'll just echo depositing whatever the amount is, and we'll do exactly the same thing for withdraw. And for the get balance, what we'll do is we'll just return the balance. So I've taken the liberty of speeding through the editing a bit there. As you can see, withdraw follows the same pattern and get balance just returns this balance. So in order to demonstrate this in the browser, what I'll do is I'll create a file called inheritance.php. Let's change the title to inheritance just to be thorough, and then what I'm going to do is add my opening and closing PHP tag. I'm going to require the account file, and I'll also create an account class, and all I'm doing here is just an initial setup just to call these methods on the account class, and then I'll demonstrate that we can call the exact same methods on a child of the account class. So deposit, we'll pass in just nominal amounts 20, and we'll call withdraw, and we'll pass in 10, and then all we need to do is go over to the browser. I append inheritance PHP onto localhost, and there we go, depositing 20, withdrawing 10. So exactly what we expected. Now let's go and create a child class of the account class, and I'll call it checking account. So checking account.php, and the way that we inherit is we use the extends keyword. So class checking account extends account. We'll need to require the account class, so we use require once. Typically that's what you'll use when you're importing class files into another one. Now because checking account is extending or inheriting from the account class, we don't actually need to explicitly define any properties or methods here. Those properties and methods will be automatically available to the checking account. So in inheritance PHP, let's require checking account. We'll create a new checking account, and what I'll do is I'll just change the name of account to checking account for these last 2 methods here. I can actually do both of those at once now because I'm using PHP Storm for this recording. And so as you can see, we're using the exact same methods what we did for the account. We've not defined any new methods in our checking account. When I refresh, everything works exactly the same still. Let's now go ahead and add that transfer method, which, if you recall from the diagram, we said this will be a unique method to the checking account. Other accounts might not have this kind of functionality. And so following the same pattern as we did for our withdraw and deposit methods, we're just going to pass in an amount argument, and then we'll just echo out transferring X amount just for demonstration purposes. And in our inheritance PHP file, we just need to call that method. So checking account transfer, and we'll just say 100 here. Over to the browser, refresh, and there you go. Now this should be obvious to you, but before I move on, I just want to demonstrate that this transfer method will not be available in the parent class. It's only available in the child class. So over in inheritance.php, let's remove these references to checking account, change them to our account class. I'll just rename these to account. Then we need to go over to the browser, refresh. So the first 2, deposit and withdraw, work okay, but when we try and call transfer, that's not available to us. Okay, check out this diagram. What I'm illustrating here is that there is no limit to the levels of inheritance. You can inherit as many times as you like, and also horizontally you can have as many classes inherit from the one class as you like. So that's what we're going to demonstrate in this next part by extending the checking account with a premium checking account, and I'm going to let you have a go at this. So here's the instructions. create a premium checking account class which extends checking account, give it a public minimum balance property and also give that a default value, echo out the premium checking account minimum balance in inheritance.php, and then call all of the methods which it inherits. Also do that in inheritance.php. So hopefully you should be okay with that. Here's my solution. So first thing I need to do is create the premium checking account class, which I do like this, and then that needs to extend checking account. I need to require once the checking account.php file, and all we're doing is just adding one public property called minimum balance, and we're going to set a default value so that we can echo that out, and we'll just call it 5,000. So for a premium checking account, that's probably a fairly realistic example. The thing that would make it unique is it would have like a minimum balance. So in our inheritance PHP file, we're requiring premium checking account.php, create the premium checking account, echo out the premium checking account minimum balance, and then call all of the other methods that it's going to inherit. And as you recall, we didn't actually define the properties and methods in the checking account, so it's actually inheriting all the properties and methods from the grandparent from the account via the checking account. So I'll zoom through that a bit, let's refresh, and there you go. So we're echoing out minimum balance 5,000, and we're also calling all the methods that have been inherited: deposit, withdraw, transfer. That all works. So I hope that was clear. You don't have to try and memorize this because inheritance is so common in object-oriented programming. It's something that we're going to cover over and over again. In this recording, we're going to look at visibility and scope. So we're going to look at public, private and protected properties. I'll explain each one and how they differ, and I'll explain the rules which apply to each, and we'll have practical demonstrations for each one, leaving you with complete understanding of the concepts. So this is how visibility works. At our most restrictive level, we have private properties and methods. They can be accessed in the defining class only. They cannot be accessed in child classes, and they cannot be accessed off object instances. Moving the scope outwards, we have protected properties and methods. They can be accessed in the defining class and subclasses only. They cannot be accessed off object instances anywhere, i.e. they can't be accessed anywhere outside of a class. Finally, our least restrictive properties and methods are public. They can be accessed in any class and anywhere in the code. So there's the schoolwork. Don't be intimidated by the theory because the practice is where it will all make sense. And let's do that now. So I'll start off by creating a new class, and what I'll have is a file reader, which will be a parent class for readers of different types of files. For example, in this one we'll have a CSV file reader. So it's quite a common thing to have in PHP. You create a class which wraps around PHP's inbuilt functions for reading different types of files, and that's the kind of thing we're creating here. So class file reader, I'll give it one public property, and we'll go through each level. I'll demonstrate public first, protected, and then private, and we'll see what is allowed and what is not allowed for each one. So we'll create just a standard PHP file, not a class, called visibility.php, and this is where we're going to have our HTML, which will display to the browser to show our values. So we'll just give it a title of visibility, and what I need to do is add my PHP tags. I need to require the file reader class, or the file reader file, so require file reader.php, and then we just need to create a new file reader. So file reader equals new file reader, and then we'll create some HTML and we'll echo out the value of the data property. So PHP tags echo and file reader, and so we're going to use the right arrow and access the data property directly, which we can do because it's a public property, and there's the rule: it can be accessed in any class and anywhere in the code. Over to the browser, visibility.php, and there we go, some random data. I'll just bump this up so you can see it. So you shouldn't have seen anything that surprised you there. Here's a little challenge for you to try out. Make this property protected and then go and test it out in the browser. What do you expect to see? Give that a go. I'll show you what happens now. So change this to protected. over to the browser, refresh, on-caught error, cannot access protected property file reader data. So because it's a protected property, we can't just access it anywhere, and PHP Storm is actually telling us this, because down in the bottom corner it's saying member has protected access. There is, however, a way that we can gain access, and we do it like this. I create a public function. I'm going to call it getData, but you can call it whatever you want, and all I'm doing is returning this data. Let's have a look at the rule. The rule is that protected can be accessed in this class and subclasses only, so we're accessing it within the class. And in order to display that to the browser, I just say file reader get data, give that a refresh, and there you go. Let's delete this now and we'll try out something else. So the rule tells us that we can access it in child classes also. Let's test that theory out. We'll create a child class and we'll call it CSV file reader. So this is a class designed for reading CSV files, and it's going to extend file reader, and because it extends file reader, it should inherit that data property, which we should be able to access. So we'll create a method called getData in this class now, and all we're going to do is return this data. So as we're extending file reader, we're going to need to require it. So require once filereader.php, and we'll just take a look at the rule again. Protected can be accessed in this class and subclasses. This is a subclass, so this should work. Let's make some changes to visibility.php. So we're using CSV file reader instead of file reader. So we'll require it, and then we'll change this to CSV file reader just to be explicit. And obviously we need to change the class to CSV file reader, and we'll change this final reference here to CSV file reader. Over to the browser, refresh, still working exactly the same. So we've proved there that you can access protected properties in subclasses. Let's change this to private now, and what do you expect would happen if we went back to the browser and refreshed? So if we look at CSV file reader, member has private access, so it's given us a warning here to tell us that it probably won't work, and there you go. But our error message is different. It told us that the property was undefined, as in the CSV file reader has no knowledge of the data property. So let's look at the rule. Cannot be accessed in child classes. They can only be accessed in the classes that define them. So that's what we'll do. Over to file reader, can be accessed in this class only. Let's test that out. So we'll go over to visibility.php and we'll just change everything back from CSV file reader to file reader. And then once we've done that, we just need to go back to the browser, and that works because we've accessed the data property in the class that defined it, and that's the only place where you can access private properties. So quick recap. Public properties methods can be accessed in any class and anywhere in the code. Protected can be accessed in this class and subclasses only. Cannot be accessed off object instances anywhere. And private properties and methods can be accessed in this class only. Cannot be accessed in child classes and cannot be accessed off object instances, i.e. just anywhere in the code. So as always, you don't have to try and memorize this stuff because we're going to repeat it so many times that by the time we get to the intermediate stuff, this will be second nature to you anyway. Okay, let's keep mixing it up. In this one, I'm going to use an eBay auction for our example. I'm no doubt that you're familiar with how it works. You have a current bid, and then you have to enter a minimum bid in order for your bid to be accepted for something. I think this is something that we should be able to hook into in order to demonstrate encapsulation and getters and setters. So I've created a bid class, and here's our opening PHP tags, and class is called bid. And what I'll do is I'll start off with a private attribute called minimum bid, and I'm going to set a default on this, which is fairly unrealistic, but it's just for demo purposes only. Otherwise I'd have to write a ton more code just to demonstrate something which shouldn't be that complex. And I'm going to add a public property called bid amount, and the reason I'm adding a public property is to demonstrate some of the consequences if your properties can be unwantedly modified by other parts of your program. I'm creating an encapsulation.php file in order to demonstrate our logic and display it in the browser. So I'm requiring the bid.php file, and all I'm doing is just creating a new bid. So bid equals new bid, and then what I'm going to do is I'm going to set a bid amount to a value which is actually less than the minimum bid amount. And because this is a public property, there's nothing preventing me from doing this. So what do you think is going to be the outcome? Let's echo something out to the browser and see what has happened. So the bid amount is, and then it will just depend on the actual bid amount which we can access. We can set it and we can also access it because it's a public property. Okay, let's go over to the console and start my server. If yours is already running, that's okay. And I do that using a PHP built-in server with PHP-S localhost and then colon any port number you want, usually 8000 or something. Over to the browser, localhost 8080 encapsulation, and there you go, the bid amount is 4. So I've been able to set the bid amount to something which is less than the minimum bid, which isn't good. We don't have protection. So how do we go about putting that protection in place? Well, the first thing I'm going to do is I'm going to change this public property to private. Then I'll go back to the browser and there we go. So we get an error. So even though we get an error, that's good because it means we can't modify this unwantedly. The way that we will modify it, and the only way that we'll be able to modify it, is by using a special method called a setter, and we're going to call it set bid amount. That will take one argument, which is the amount that we wish to set, and our bid amount gets set to that amount which is being passed in. So this right arrow bid amount equals amount. So whilst we're setting the bid amount to the amount, we still don't have any protection. Our minimum bid can still be set to an amount which is lower. So the way that we tackle this is we do a check before we set that amount. So if the amount is less than the minimum bid amount, then what we would do in real life is probably throw an exception, but we haven't actually covered exceptions yet, so we ain't going to do that. What we're going to do is, if the amount is less than the minimum bid amount, we're actually going to set the bid amount to the minimum bid amount. So that'll teach the user to attempt to put in bogus numbers. So how should we handle if the amount is okay? Your first instinct might be to do this, to just put an else conditional in there. So if the amount is less than minimum bid, the bid amount gets set to the minimum bid, else the bid amount gets set to the amount. I prefer to keep my conditionals to a minimum, because the more of them you have in there, the harder it is for another developer to follow the logic. What I'd prefer to do in this situation is just return. So if the amount is less than the minimum bid amount, set the bid amount to the minimum bid and then just return, and that breaks out the function. You're done. If, however, this condition isn't met, the amount is good, then that gets completely ignored, that block there, and all we do is we just set the bid amount to the amount. Okay, let's put this into practice. So bid set bid amount, and we'll keep with the same value, 4 again. So that should match the condition that we specified in our if block. We've also got this display part here, so this isn't actually going to work because bid amount is private. So here's a quick challenge for you. How do you suppose that we should modify our two files in order to display the bid amount in encapsulation.php? Use your intuition and give it a go. Here's the solution. We create a getter. So where we have a setter, we also can create a getter, and all that the getter does is just returns the value. It's a public method which returns a value. So public function get bid amount, return this bid amount, and then what we have to do is go over to encapsulation.php, and instead of just accessing the property, we access the getter, and that will work. Over to the browser, give it a go. Encapsulation.php, the bid amount is 5. So we tried to set it to 4. That's going to force our if conditional to be true because the amount is less than the minimum bid amount, and the minimum bid amount is 5. So we set the bid amount to the minimum bid amount. If, however, we set it to a value which is equal to or above the minimum bid amount, so if we set it to 10 now, go over to the browser, and that's happy to set that to that amount. So this conditional is false, and this line here gets executed instead. because the amount was 10. So that was encapsulation, the bundling of data with the methods that operate on that data. If we want to modify the data, we use setters, and if we want to access the data, we use getters. So the functionality is defined all in one place and not in multiple places. The functionality is defined in a logical place, i.e. in the same place as where the data is kept, and the data in our object can't be unexpectedly modified by code outside the class, which, as you saw, can cause problems. Welcome to this final recording of the chapter, and well done for making it this far. You're making really good progress. This one's about abstraction, which is another one of the 4 pillars of object-oriented programming. I'm going to be approaching it from a high level initially, and we'll get into it in more detail and more depth as the course progresses. So first of all, what is abstraction? If you look around the web, you'll see various definitions. This is probably my favourite, and it's the one which applies most to us as far as this course is concerned. Abstraction is the process of hiding the internal data and the implementation from the outside world. So if I tell you why we use it, then it should make a lot more sense. We use it in order to provide an interface which is as simple as you can make it. So let me illustrate using a high-level example. Think about when you use the internet. When you load a web page in your browser, there's a lot of complexity which goes on behind the scenes which you don't see. For example, with this Airbnb page, I'm using Airbnb because we're going to use that in a code example shortly. But when you request this page, there could be loads of stuff happening. For example, here we've got data, so it's obviously querying a database. We can see a search bar at the top. Search is massively complex, so it's probably caching some data in memory to assist with that. We've got images. Images are most likely stored with a third-party service like Amazon. You've got your CSS and your JavaScript, which are probably working to display things differently on a desktop than on a mobile phone, and also almost certainly showing you different content on different devices. For example, the images you see on a desktop will be the same versions of different images of what it would send you on a mobile phone, where it would use smaller images. So massive complexity, but you don't need to know any of that, and you don't get to see any of that. All you need to do is click on a link or put an address in your address bar, and from a high level, that is what abstraction does. It hides away the details and gives you a simple interface and a simple user experience. So let's have a go now at turning this concept into code. What we're going to do is we're going to create a reservation class, as in an Airbnb reservation, and we're going to, in this scenario, we're just going to cancel a reservation and think about all the things which might be involved in doing that action. So in the same folder, chapter 2, I've created a reservation.php file. I'm just creating a class reservation. So imagine now you're another developer, you're working on an Airbnb site, and you need to put a cancellation form on the front end. The only thing on the back end that your form will interact with is this one public method on the reservation class, which is to cancel. That's all you need to do. All you would do is just call this method cancel, and everything will be handled for you. So apart from the obvious things, such as updating the database to show that the reservation is cancelled, let's have a think about all the other things which might be involved. With software development, there's always a lot more to it than meets the eye, even to the people that are writing the software usually. So we might want to check whether cancellation is an actual option in the first place. We may want to refund the guest. If you think about refunds, there might be a lot of complex logic involved in that. It might be fully refundable, it might be part refundable, might not be a refundable reservation. And also, on the subject of refunding a guest, you need to have a guest in the first place. So we're going to have a guest class involved. So you can see now the complexity is building up, and this is just a couple of things. I need to make the room available again, because once you reserve the room, obviously no one else can book it. Now you're making it available again. Obviously you need to update the database to say that, so it starts appearing in listings again. And you're going to need a room class. Think about the real world. You're going to need to notify the host, but how are you going to notify them? You might have different rules for what methods you use to notify them depending on how close you are to the reservation date being fulfilled. For example, if it's like a week in the future, you might just send them a notification in the app. But think about, what if you're on the day? Do you send them an email? Do you send them an SMS? These are all considerations, and behind each one there's different levels of complexity. So here we're going to need classes for notification as well as for email and SMS. And speaking of email and SMS, they're likely to be third-party delivery services that you're using, which your app will have to communicate with. You're also going to need to send a confirmation to the guest. I could go on and on. This list could get really long, and in real life it will be, but we'll leave it there and we'll start to implement a couple of these things, not all of them. So up until this point, you've probably noticed that I've only actually used private properties. I've not used any private methods, and I've sort of held them back in order to help illustrate this point. So what we're going to do here was just add a couple of private methods for the sending of a cancellation notification to the host, and also for refunding the guest. And so the reason that these are private is so that they can't be accessed from the outside world. The only thing that the client code has to work with is the cancel function. Calls that function, everything gets taken care of. Nice, simple interface, mission complete. Keeps our code nice and modular, and each module doesn't need to know how the other modules implement that functionality. It just needs to be able to call upon that functionality. And as you'll see later on in the course, we'll show how we can switch modules out for different ones which perform the function but slightly different. I'll introduce abstract classes, abstract methods and interfaces, which are all tools which we use to keep our code abstract and flexible. It's all part of abstraction. So I've now created my two private methods. In order to send a cancellation notification to the host, we're going to need a host. So like I said earlier, we would use a host class. Rather than create that, I'm just going to fake it for demonstration purposes, just to keep us focused. So we'll pretend that this is a host class, and in order to refund a guest, you would need a guest class. I'm going to do exactly the same thing. So I'm creating a private guest property which represents a, in this case, imaginary guest class. What we'll just use is a string to represent that guest class. And then what I'll do is I'll just write some placeholder code to show that we're sending a cancellation notification and that we're refunding the guest. And like I say, the functionality for performing these functions, it could be very, very complex. Could be all sorts of things, other classes being called and other methods. But as far as our client code is concerned, we don't need to know. All we need to know is that we just call the cancel method, and all of this will happen. At the moment, we're looking really at the what and the how. When we get further on into the course, we start looking at the where, when and the why. I'll encourage you to think about how you'd like the code to be used by other developers before we write it. I find that writing code like that really helps me stay abstract, helps me make a simple interface for other developers, and they're really the most important people. Forget the end users. You're writing code for other developers. Always keep that at the back of your mind and you'll naturally write better code. Okay, we're going to need to try this stuff out, so what I'm doing is I'm creating a abstract-basic.php file in the chapter 2 folder. This is going to be HTML page, so create HTML and body tags, opening and closing PHP tags, and then we just want to try out our code. And all we're going to do is we'll require our reservation class, and we're just going to call the cancel method on a reservation object. So require reservation.php, and I'll new up a reservation object. So reservation equals new reservation. Then all I need to do is just call cancel on the object, and all that's going to do in this case is just print out those lines that we added to each of those methods. Let's just go and remind ourselves what we put. So we're sending notification to this host, so that will be a string in this case. We'll add our break tags and just copy and paste that to this one here as well, and then we're saying refunding this guest. So we need to call those methods from our public cancel method, and I just need to append on abstraction hyphen basic, because we're going to go into this in a lot more detail. And there you go, sending notification to host class, refunding guest class. And just to be thorough, I'll add an extra line on here which just reminds us that there's a ton of other stuff that's also going to happen, which makes up part of cancelling a reservation. I need to change these quotes for double quotes because I'm putting in a single quote there, and a lot of other stuff that you don't need to know about. And there you go, and a lot of other stuff that you don't need to know about. So that covers your introduction to abstraction, and it also brings us to the end of chapter 2, and sincerely well done for sticking with it this far. In this recording I'm going to look at object and class data in PHP, so I'm talking about properties, class constants and static properties. I'll show you how they're defined and I'll demonstrate some practical uses of all three. Going beyond that, I'll also cover some of the other stuff, including what is and isn't allowed, and I'll finish off with some typed properties. The way I'm going to start off here is with a brand new chapter 3 folder, and inside of that I'm creating a file called calendar.php, which will hold a calendar class, and I think this should be pretty good for demonstrating the things I need to demonstrate. We're going to do some class properties, class constants and some static properties also. So let's start simple. I'll just add a simple public name property. I can use the same file to perform our logic, so I'll new up a calendar. I'm going to assign a value to the calendar name, and then all I'm going to do is print that out. So a nice easy one to get started. I'm going to stick a new line on the end so it renders cleanly in the terminal. Over to the terminal, php calendar.php, and there you go. Okay, so in addition to class properties we can also have class constants. So constants are owned by the class and not the objects, and obviously their value remains constant, and we define them like this and we access them like this. So we use the class name, double colon, and then the constant name, and I'm putting the line break on the end. So this is called a scope resolution operator, or double colon, and as you can see we're accessing it off the class and not the object like we did for the name. So let's go over to the terminal, and the value is 12. Now to access constants within the class we use the self keyword followed by the double colon. So I'm just creating a public method here to demonstrate, and again using the double colon, so self double colon followed by the constant, and we'll go down at the bottom and we'll just call that method off of the calendar which we created. So calendar, get month and year, and line break. Over to the terminal, run the file, and the exact same result as when we called it directly off the class. So I'm going to revert back to where we called it directly off the class. Just like you can with normal properties, you can also give constants visibility. So I've changed this to private. Over to the terminal, and as you can see we're getting an error because we're trying to access a private constant. And of course we get the error because we're trying to access it outside of the class. You can only access private properties and constants within the class. So here's the rules. Regular properties, they belong to the objects and their values can vary between objects. Constants, value remains constant and it's associated with the class. Sort of in between the two we have static properties whose values can change, but the value remains the same for all instances of that class. So I'll give you a demonstration. Here's how we actually define them. We use the static keyword, so I say public static, and I'm going to demonstrate this using the number of days in February, which I'll set a default of 28. And first off we'll just print that out, so I'm accessing it using the class and the double colon. And you'll also notice that we didn't drop the $sign like we did with normal properties. The $sign remains. Over to the terminal to inspect, and we get 28, which is what we used as a default. Now watch what I do here. I'm going to increment the value using the class, and then using the object that we created I'm going to access the value. So what do you think we will see here? Back to the terminal, and it prints 28 and 29. So 28 is this first line here, it's what we initially defined. Then we incremented the value and then printed it again, except this time accessing it from the object. So we use static properties when we have a value which we want to remain the same for all instances of that class. And so here I'll show you practical usage, because quite often what you want to do is count objects which have been instantiated from that class. So here I'm using the constructor to increment a static count property by saying self : count and then increment using ++. So we'll print out the count, and as you can see we'll get 1 because we've only instantiated one calendar object. Let's create a new one, so we'll call it calendar 2. So this time our count is 2, because every time a calendar is created, then the construct method is called behind the scenes and the count is incremented. That's an introduction to static properties. Now what I'll do is I'll show you some of the things which are and are not allowed when you're defining these class properties. So here's an array. The value for this array is constant. Nothing needs to be evaluated. We're going to get back spring, summer, autumn, winter. So this is allowed, and I'll just demonstrate that in the terminal. There we go, spring, summer, autumn, winter. However, you can't have something which is the result of an expression, so I can't use a function to merge two arrays together and say give me the result of that. This isn't allowed because PHP has to work this out at runtime. It's not something which is this isn't something which could be compiled and stored and given an address in memory. So as you can see there, constant expression contains invalid operations. Now some things are allowed, such as basic mathematics. So I'll demonstrate using number of weeks in the year. So I'll take 365 as the days in the year and I'll divide that by 7. So that should give me the number of weeks in a year containing 365 days. Let's check that out in the terminal. So 52.14 blah blah blah. So you might be thinking, well, why not just call it 52.14? And that's a very good question. But the only thing I can think of is it might just make more sense to do this, and then you can show other developers how you've actually arrived at this bizarre number 52.14. Let's have a look at something else which is also allowed. So you can have predefined constants. So I'm going outside of the class here and I'm defining a year constant as the number 2021. And so inside of the class I'm going to set the year, a year property, to the year constant. Let's print this out just to show you that I'm not making this up. And I'll also append a new line, and then let's go over to the terminal, and there you go, 2021, just as we expected. What shall we have a look at next? Okay, here's something which has been around in other object-oriented programming languages for a while, which is fairly new in PHP, and that is typed properties. So as you can see here, I'm stating that the name property should be a string, weeks in the year should be a float, and year should be an integer. So with that in place, what would happen if I tried and set weeks in the year to the string 52? Let's print that out and see what we get back in the terminal. And we have an error, uncaught type error, typed property calendar weeks and year must be a float, but string was used. So it gives us some protection. So I'll change this back to a float to make it work. One thing I like about this is it does a check for you, so you don't have to be writing if conditionals to make sure that you're getting the right kind of value. It does it for you. How about if I set weeks in the year to be null? Now as you can see, I got a squiggly line which kind of gives it away. It's not allowed. If you give something a type such as a float, you can't actually initialize it as null. However, you can put a question mark in front of it like I've done here, and then that will accept both the type as in float, or it'll also accept null. So if I do initialize it as null like I have done there, then it will accept that perfectly fine, no problem. I'll change it back to a float to demonstrate that it will take either or. So 365 divided by 7, so it's telling you it's a float. It will accept null or float if you use the question mark in front of the type name. Okay, here's a list of types which are allowed: boolean, integer, float, string, array, object, iterable, self, parent, class or interface name, and as you can see at the bottom we have question mark and type. And if you read the description, it tells you that the property must be the specified type or null. In this recording I'm going to cover magic methods. Magic methods are a special kind of class method which you don't call yourself, but which are called behind the scenes by PHP when you get your objects to perform specific functions. I'm going to use a connection example, as in digital conferencing connection such as Zoom, Skype, etc. And that will give us a good opportunity to show you what magic methods are and how and when you can use them. I'll start by creating a new file called connection.php, and this is going to hold my connection class. So opening PHP tags, and class is connection. So here's the list of magic methods, about 15 of them. The good news is we've already been using the most famous one of all, construct, up until this point. I want to keep count of my connections, so the way I'm going to do that is using a private static property called count, and then I'm going to add my constructor, and inside that constructor, every time this is called, it's going to increment the count property, and the construct method will be called behind the scenes whenever we create a new connection object. So let's create a file where we can go and test this out. I've called this magicmethods.php. Just kick off some HTML there, opening and closing PHP tag, and I'm going to require the connection PHP file. And so what I want to do is just new up a new connection with connection1 equals new connection. Construct should get called and our count should be incremented, all behind the scenes. Let's put a line in here where we can echo something out and get some feedback and see if this has worked. And we're just going to say what the current number of connections is. Now our count property is private, so we can't just access it. We're going to need to do a bit of work before we can do that. So, quick challenge for you if you're up to it. Using this class, create a solution for accessing the count property in Magic Methods and then display the value in magicmethods.php. Here's my solution. Have a go at it if you fancy it. Public function get count, and all we're going to do is just return self count. Simple as that. I'll grab this comment and I'll cut it and I'll copy it over to my Magic Methods file, just so we're keeping track of what we're doing. And all we have to do is just append on the end of this connection 1, and then instead of trying to access count statically, what we're going to do is we're just going to access the getCount method, and I'm looking to append magicmethods.php. Okay, so far so good. Number of connections is 1. That's what we expected. Just to prove that this is working, let's add a second connection. Refresh. Number of connections is 2. Let's now unset a connection and see what happens. That's not good. The number of connections is still 2, even though we've got rid of 1. Let's double check to make sure it's really gone. So I'll use print R, which allows you to view variables in a human readable format. Over to the browser. Yep, it's definitely gone undefined variable. So that's definitely gone. We can no longer reference that, but our number of connections is still 2. So we have a problem, but it's an easily solved problem. So like we have the constructor, we also have a destructor, which is simply this, underscore underscore destruct. And destruct is called as soon as there are no other references to a particular object. So we unset it, and when we unset it, if we have a destructor, then that destructor will be called behind the scenes when that action is performed. So I'll let you have a go at this. How do you suppose we will reduce the count when that object is unset? Have a go, you should be able to get this one. Just take a glance at the constructor if you need a little clue. Here's my solution. So self, double colon, count, and then negative negative to decrease the count by 1. Let's go over to the browser, give it a refresh, and there you go. Now the number of connections is 1. That works perfect. I'll comment it and uncomment it just to double check. Always double check your work, so uncomment. There we go, yep, that's definitely working the way we want it to. Okay, you ready for a new one? Let's try get. So this will be underscore underscore get, and it's the magic getter. We'll use a connection ID, which will be a string for this example. And if you recall from the properties recording, we could add dot blocks, and we'll just put in a bit of an explanation as to what this is for other developers. So it's a string, and it is the connection identifier, and it's just a private regular property. This one isn't static. Let's create a setter for that property. So we'll just call this public function set connection ID. And so to give this a sense of realism, what we'll do is we'll pass in an IP address and concatenate that with a count, and we'll call that the connection ID. So this connection ID equals IP address underscore self count. Now the IP address, this might be something that you want to protect, because at the moment someone could just pass in anything and that would be accepted. So what we'll do is we'll perform a check first, and we'll validate that it is a valid ID address, and if so, we'll set the connection ID. So we can do that using a function called filter var. I'm not sure if you've seen it before. And what that does is it takes a value and performs a specific kind of validation on it. And what we're performing on this is filter validate IP, and that will validate that it's a legitimate IP address. If that condition isn't met and the IP address fails, we're just going to say die, and we'll put out a string, not an IP address. When we get onto exceptions, we'll put in some better error handling. Okay, so it's a private property, so we're going to need some way to access it. Now what we've learned up to now is to use getters like so. Get connection ID, which is perfectly valid, and this is the most common way of doing this. However, what I'm going to show you with the magic getters is an alternative way of accessing this, because say for example, here's where you might want to use it. What if you have a growing list of private and protected properties, and you might even have dynamic properties which you're adding to the class on the fly, which is something we'll look at later. It wouldn't be practical to have a getter for each one. Okay, we have the setter here because we need it for that protection when we're setting the value, but there's actually an easier way of, or a more efficient way of accessing those properties. So in order to demonstrate this, I'll add a second private property for the conference ID, and what we use is something called the magic getter, which is underscore underscore get. This method will get called behind the scenes when we try to access private or protected properties. Like it says here, used for reading data from inaccessible, i.e. protected or private properties. And the way that we most typically use it is this. We just say return this and the name of the property that we're trying to access. So let me try and explain that a little bit better. In the example we're going to use, we're going to try and access connection ID off an object. Connection ID is what will get passed into the magic get method. So that's what we're going to access. In effect, what we're going to be doing is this. When we try and access connection ID, it'll call this magic get method, and it's just doing this basically under the hood. And so now we can access connection ID, conference ID, whatever. We don't need to create getters for each of our public and protected and private properties. So don't just take my word for it. Let's go and give this a go. So we'll set a connection ID. I'll just test that that works first. Let's set it to something which is legal, not a valid IP address. Okay, that's working well. Now let's print these values out to the browser just to prove that it really is working. So as you can see here, I'm accessing the conference ID as if it was a public property, doing the exact same thing with the connection ID, which I shouldn't be able to do because it's a public property, but we've created our getter, so it should work. Over to the browser, refresh, we see our conference ID and we see our connection ID. To finish off, we'll use the magic toString method. So at the moment, if I wanted to echo out my object or treat it as a string printed out like this, I'm going to get an error. Encore error, object of class connection could not be converted to a string. So the magic toString method actually allows you to represent your object as a string. So when I say print connection 1, it will print a string which I have built in the toString method of the connection class. Let me show you exactly how this works. Underscore underscore toString using camel case, and like I say, it returns a string representation of the object. So like it says here, the class decides how it will react when it's treated like a string. So the one big essential requirement here is that we actually return a string. Let's document that using our doc blocks, and the way we document it is we say @return string. So you're telling anyone who reads this code that you must return a string from this method, and we'll just build up a string, conference ID colon conference ID, and then we'll put in a line break, and then connection ID is this connection ID. So this is quite a typical use of the toString method. You'd return a string which contains some of the data or some of the information regarding that object, and we're just printing that out here. Conference ID 1234, connection ID is IP address appended with the count. So let's recap. We've covered construct, which you already knew about, destruct, which is called when the object no longer exists, get for accessing inaccessible properties such as protected and private properties, and we finished off with toString, which allows a class to decide how it will react when it's treated like a string, and we just returned some of the class's data. So I hope you found that useful. Here's the full list. There's roughly 15 of them. We've just covered some of the basic ones for now, but we'll definitely be looking at some of the others in the future. I think for the time being it was just good to introduce them to you, let you know what they are, how they work, and what makes them unique. In this one I'm going to cover abstract classes, so I'll show you what they are, why and how we use them, and then I'll demonstrate using a fairly common example, which is that of representing database tables with objects. It's a technique which is common to all major PHP frameworks such as Laravel and Symfony, and we will come on to covering that stuff later in the course. So here's my database admin tool. As you can see, I've created a database with a couple of tables, products and users. I'm going to create classes which represent each of these tables, and those classes are going to inherit from an abstract parent class. So for lack of a better name, we're going to call this abstract class data model. Now an abstract class is one which you will never instantiate. There will never be an instance of a data model class, and it would be meaningless anyway because we don't have a table in the database called data model. We need to extend this with our concrete classes. That's what we refer to as the classes which we instantiate, and the abstract parent provides properties and functionality which is shared amongst the child classes. Okay, so enough jibber jabber, let's get into this. I'll start off by creating the data model class. So as you'll see, we create it in pretty much the same way. We use the class keyword, except in front of that we also add the abstract keyword. Adding the abstract keyword will now mean that PHP will not allow me to create an instance of a data model class. We're going to need some properties and methods in order to give this a sense of realism. I'm not actually going to really connect to a database because there's quite a lot of setup involved in that, and I don't really want to get sidetracked. I just want to explain the concept. So I'm giving this a property of table name, and I'm just going to give it a default random table name value. Also a save method, which is quite common for this kind of class, and I'm just pretending that I'm saving something to the database. This is just a placeholder string to give an idea of what this method should actually do in real life. Now let's create a file where I can go and play with this stuff and demonstrate it in the browser. So in the same folder I'm just going to create a file called abstract classes.php. I'll just remove this opening PHP tag, replace it with a bit of HTML. I'll give the file a title, abstract classes, and then within the HTML body I just add my opening and closing PHP tags. I need to require the data model file, so require data model.php, and I'm going to try and instantiate an instance of the data model class. One of the good things about IDEs like PHP Storm is they tend to tell you if something's not going to be possible, as you can see here, and it gives me a message in the bottom corner, cannot instantiate abstract class data model. I'm still going to give it a go because that's the kind of reckless maverick that I am, and I'm going to try and call the save method on it as well. So over to the browser, and it's telling us we can't instantiate abstract class data model. The reason why we can't instantiate it is because it's abstract. And abstract classes aren't supposed to be instantiated, they're supposed to be extended. So let's do that now. So over to the database again. As you can see, we have this products table with a couple of properties, name and price. Let's create a product class in the same folder. So class product extends, and we're going to extend data model. So it'll inherit the public and protected properties and methods from the data model, and I'm going to add a couple of private properties of my own, which are the name and also the price. And you'll notice that I've also given them property types of string and float. It's good to get in the habit of using stuff as and when you learn it. Okay, I'm now going to create some getters and setters for each of these properties. Again, for a class like this, an entity class or model class, whichever you want to call it, this is also quite typical. You'd set your properties and then you'd call the save method to persist it to the database. If you're wondering what these things are here, I apologise not covering them yet. These are type hints, and they're basically telling PHP what kind of values or what type of values to expect. That's stuff that we are going to cover, and it is coming up shortly. Okay, let's round off this class by requiring once our data model.php file, and then what I want to do is go over to my abstract classes .php file. I'm just going to change all the references to data model. I'll delete this. So I'm requiring product.php. I'm newing up a product with product equals new product, and then same as I tried for the data model, I'm going to call the save method. So let's go over to the browser and give that a go, refresh. Okay, our error is gone, that's good, and it's saying saving data to table name, random table name. So it would be better if we actually created our own table name property in the product class. By doing that, when you recreate the same properties and methods in child classes, it's the ones in the child classes which are referenced, and we call this technique overriding. Okay, so back to the browser, give it a refresh, saving data to table products. Hopefully now you've got a grasp of how that works. Do you want to give it a go yourself? I've written some instructions here, so here's what you need to do. First, create a user class to extend the data model class. Then on that class, set the table name. Over in abstractclasses.php, new up a user and call the save method, and then just go over to the browser and check your work. Okay, give it a go. Hopefully you should find it fairly straightforward. Here's my solution, except I'm not going to include the getters and setters this time. That was just to illustrate how these kind of classes are used. So I'm requiring once the data model in my new user class, and then I'll just set a table name to users. So protected string table name equals users. What I need to do then is go over to the abstractclasses.php, change the references to product as to user, rename these just for continuity, refresh, and there you go, saving data to table users. In this recording, I'm going to look at abstract methods. I'll show you what they are, how we use them, and where you'll use them. And for a bit of a change, I'm going to demonstrate using some mathematics and some geometry. I'll start things off in the Chapter 3 folder by creating a new class, and this is going to be an abstract class, and it's called 3-dimensional shape. And this is purposefully designed to be extended by concrete implementations, and the examples I'm going to use in this recording are a cylinder and a sphere. So you won't instantiate a 3-dimensional shape class because it means nothing, but you would instantiate a child class, a more concrete version such as the sphere and the cylinder. Now I'm adding a volume method here, and this is a method for calculating volume. So if you think about the different shapes that we're going to use, the calculation is going to be different for each one. And because the calculation is going to be different for each one, I can't put the code in this 3-dimensional shape parent. But what I can do is make the function abstract, and that means that each child of the 3-dimensional shape must implement a volume method. And you'll notice that I'm removing the body here. We only define the name, visibility and params for abstract methods. The body isn't needed because this is a contract which is saying if you extend this class, you must implement this method. So let's do that now. In the Chapter 3 folder, I've created a class called cylinder, and that extends 3-dimensional shape. The red squiggly line is PHP Storm telling me that I must implement a volume method in this class, and it's in this method that I'll define the body. And one thing to note is that the signature, i.e. the parameters and return type, must match those of the abstract method in the parent. So let's go over to Google and find out how to calculate the volume of a cylinder. So it's going to be pi multiplied by radius squared multiplied by height. That's a good candidate for a doc block, so you can explain to other developers how you're calculating this. PHP has built-in functions which will help us with pi and radius squared. The dimensions is going to be an associative array because it's going to be different for each kind of shape, so I think an array is probably the easiest way to do this. So it'll have a radius key and it will also need a height key. So pi multiplied by dimensions radius squared multiplied by dimensions height. Let's require once our three-dimensional shape.php file, and then we're going to need a file where we can go and test this out. So I'm creating just a standard PHP file called Abstract Methods in the same chapter 3 folder, bit of HTML, change the title to Abstract Methods, and then I need to require the cylinder.php file, and I'm going to create a new cylinder. Cylinder equals new cylinder, and I'm thinking we can actually improve our design here by passing in the dimensions to the constructor. When you make this kind of improvement, it's called refactoring. So we're not going to change how the code behaves, we're just going to make it more logical. And we're going to do that by putting a construct method in the three-dimensional shape abstract class. That will take the dimensions array, and then we'll create a dimensions property on the class. And so in our methods, instead of passing in the dimensions array, we'll just be able to say this dimensions. And this will make it mandatory to pass a dimensions array whenever you create a new shape or three-dimensional shape of any kind. So we can remove the dimensions argument from the methods. In the calculation itself, I'm replacing the dimensions variable with the dimensions property, and I'll do that for both radius and height. And then also in the doc block, I'll remove this param here. And let's go and pass in an array to our constructor. So I'll say radius equals 5, and for the height, I'll call that 10. So I think it makes quite good sense to pass in these dimensions when we create the object itself. Let's now calculate the volume, and all we need to do is just call cylinder volume. Now what I'm going to do is print it out using print_r, and I'll just go over to the browser and see what we get. So I'll append the file name onto the end of the URL, and that doesn't look right. What have I done there? Let's go back to the file. Yep, needs to say PHP. Okay, back over to the browser, refresh. Okay, we have a number 785.398 blah blah blah. I've no idea if that's right, but I know someone who does. I'll put my dimensions into this Google helper here, and hopefully I'll get a similar number, 785.4. That's obviously been rounded, but it's good enough for me, 785.39. Okay, so your chance to have a go should you accept the challenge. Here are the steps. Create a sphere class to extend the three-dimensional shape abstract class. Add the mandatory volume method to calculate the volume of a sphere and return that value. Add a new sphere object to the abstract methods.php file and call the volume method on it, and then all you need to do is print out the result in the browser. So here's how you do it. Have a go at it. Class sphere extends three-dimensional shape, and I've got that squiggly line because it's mandatory to implement this volume method, and so I need to figure out how to calculate the volume of a sphere. So over to Google, and Google tells me that it's 4 divided by 3 multiplied by pi multiplied by the radius cubed. So let's add that to our volume method. Return 4 divided by 3 multiplied by pi, and then you multiply that by radius to the power 3, which we can do using this power function. And on the dimensions property, we will have an array which contains a radius key. So we assign the dimensions property in the three-dimensional shape constructor, and when we create a sphere, we'll just need to remember that we'll need a radius key for the array. In my sphere file, I've required the three-dimensional shape.php file. Now in the abstract methods file, I require sphere.php, and I need to create a new sphere. and it's in the constructor where I set this radius, and we'll stick with 5. And then all I need to do is call the volume method on sphere. So sphere volume equals sphere volume, and I just have to print that out and then go and check my work in the browser. So we'll go over there now and we'll get 523.59. Let's go and check this with Google's calculator and see if that will give us the same value. Put 5 in there. Okay, 523.6. That's close enough. So I'm going to finish off with a couple of things. One of those will be type hinting, where we tell PHP what type of value to expect. And I want to demonstrate something else to you as well. So as you can see, our number of dimensions varies for each of these shapes. For certain types of shapes, such as cubes, cuboids, the number of dimensions will be fixed, i.e. length, height, width. So I'm going to introduce an extra level of inheritance. So my sphere, my cylinder, will now inherit from a non-cuboid shape class, which inherits from the three-dimensional shape. And the reason that I'm doing this is to show you in what circumstances you can be exempt from having to implement the abstract methods. Now, this non-cuboid shape, much like its parent three-dimensional shape, it's not something that you would instantiate. It's an abstract notional class. So I'm going to make this abstract, and in doing that it means that the non-cuboid shape does not need to implement the volume method. That responsibility will get passed down the chain to the child classes of the non-cuboid shape. So I'll require once the three-dimensional shape.php file, go over to cylinder. I'm going to change this so it extends non-cuboid shape. I'll change my require over to sphere, do exactly the same thing. Sphere extends non-cuboid shape, need to change the require once to non-cuboid shape also. And so let's go and run the code. Nothing breaks, exactly the same behavior. That was the sphere. We need to check the cylinder volume also, so I'll move that up there, change that to cylinder. Excellent, so that's passing it as well. No change in behavior, nothing breaks. So let me just clarify that rule. If a class extends the three-dimensional shape, then it must either implement the volume method or also declare itself abstract. Okay, type hints. So this is a type hinted argument. This is a type hinted return. When I type hint array in my method signature like this, what it's saying is that whatever gets passed in must be an array. So I'm going to change this to an integer, and then we'll go and run this in the browser and see what happens. So there you go, argument 1 past three-dimensional shape construct must be of type array integer given. So that's pretty good. It's another thing which protects our application, and it means that we don't have to do checks to ensure we're getting past the right values, because PHP is doing it for us. So I'll return this to how it was, and we'll go and have a look at the other one, which was type hinted returns. So over in our sphere class we said that the volume method must return a float. Let's comment that out and return a string. Any string will do. I think the value was 5 point something if I can remember rightly, so I'll just return a string 5ish. Over to the browser, refresh. Okay, return value of sphere volume must be of the type float, and a string was returned. In this recording I'm going to look at interfaces in object-oriented PHP. I'm going to look at what they are, how you create them, and where you will use them. And I'll demonstrate using a client for contacting third-party APIs. So let's start off with the questions. What are interfaces and how do you create them? So code along with me and I'll explain as we go along. I'm creating an interface here, and it's going to be called Weather API Client Interface. So it's just like creating a class, except I swap this class keyword for the interface keyword. And just like that, you've created your first interface. And an interface is like a contract. You don't extend it like you do with classes. Instead, you implement it. And when you do implement it, you're saying that you're going to adhere to it. You're going to implement the methods which it defines. So fairly similar to abstract classes and methods in that respect, and also similar in that I don't define the body of the methods. That is done in the classes which implement the interface. So I've created a Weather API client interface here, and I'll now create concrete classes which implement this interface. The example I'm using for this recording is a client for contacting a third-party API. So I'm going to look at a couple of third-party APIs which are weather-based APIs, I want to get the same or similar data back from both of them, but obviously they're both different APIs and they're going to behave differently. This first API is called Dark Sky and it requires me to pass latitude and longitude coordinates. The second one is called Open Weather Map, and instead this one requires a city name. So even though these two APIs work differently, my two clients are going to appear like they both work the same by implementing a common interface and hiding away the different functionality behind the scenes. As you can see, I get this squiggly angry red line, and that is because I need to add a get forecast method when I implement the weather API interface. Not only that, but it must have the same signature, i.e. it must take a city as a parameter. Next, over to the Dark Sky API client, and here I'm going to implement the same interface. So Dark Sky API client implements weather API client interface. Again, I have to create the method get forecast, and I also have to add city as a parameter. So no matter whether you're using Dark Sky API client or the Open Weather Map API client, the way that the rest of your code interacts with these two clients will be exactly the same because they both implement a common interface. Let's figure out how we can make this work. So the Dark Sky API, like we said, it needs latitude and longitude coordinates. So the first step we can do is get the latitude and longitude of the city that we're passing in, and then we can call the Dark Sky API using those latitude and longitude coordinates. Now I'm not going to physically write the code to get the latitude and longitude of the city or call the API. I'm just demonstrating how you would go about normalizing that behavior so that on the surface you have something which appears to work the same way for both Dark Sky and Open Weather Map. For the Open Weather Map client, there's one step less because that uses a city anyway. So let's require once our Weather API client interface file, and we need to do the same for the Dark Sky API client. So require once Weather API client interface, and then let's create a file where we can go and play around with this stuff and display stuff in the browser. So I've called it interfaces.php. I'll change the title to interfaces, opening and closing PHP tags, and we'll start off with the Dark Sky API client. So require Dark Sky API client, and then I'm just going to create a new Dark Sky API client, but I'm going to call it Weather API client because it's less specific, it's more abstract, and it's a much more suitable name should things change, as you will see shortly. So we'll get a forecast back from the Weather API, or in our case we'll pretend to get a forecast back from the Weather API. I'll give this a sense of semi-realism by adding a weather app heading, and then I'm just going to echo out that forecast to the browser. And then all I need to do is go over to the browser itself, and the address is localhost followed by my port and then interfaces.php, and that's just echoing out it is raining in followed by whatever city name I gave it. So let's imagine that we've been using our Dark Sky API client for a while, and then all of a sudden it becomes unavailable, or for whatever reason we can't use it anymore. We're going to need to find an alternative. Now, if we've been good developers and we've implemented interfaces, it will make life a lot simpler than if we hadn't. All of our code which performs the action of getting a forecast can stay exactly the same. As long as our new client implements the get forecast method, it means all we need to do is just swap out the old class for the new one. And on the surface, when we refresh, exactly the same, but behind the scenes the Open Weather Map client, when the get forecast method is called, that will go and do what that needs to do in order to get the forecast. So we could have multiple parts of our application which call the Weather API client, or just different parts of our application which rely on others. If you've coded to interfaces and contracts, it will make life a lot easier for you when things need to change. So that's been an introduction to interfaces, what they are and how you create them. In the next one, which is polymorphism, I'll show you just how powerful they really can be when you inject them into methods. In this recording, I'm going to cover another one of the object-oriented programming fundamentals, polymorphism. Polymorphic objects are the shape-shifting superheroes of object-oriented programming. They are objects which can take on many forms, and as you'll find out as I will demonstrate to you, they're both powerful and flexible. So here's what we're going to do. I have a couple of files which are inventory files. One is in CSV format, as you can see here. It has a header and then 3 rows of data. And here I have an inventory file in JSON format which contains the exact same data, but it's just in a different format. I'm going to build a mini application which is able to read either of those files in either format and take the content and return me this, an associative array in this exact format. So no matter whether it reads the CSV or the JSON, it will return me this array in this format. My code should be able to handle either scenario seamlessly and without making any adjustments because it will be polymorphic. Before I get into a full-blown explanation of polymorphism, we're just going to build out some of this application, so code along with me. I've created a class called CSV file reader, and that will implement a interface called file reader interface. So let's go and create that. File reader interface. And so as you can see, instead of the keyword class, it uses the keyword interface. This is going to act as our contract, so the classes which we create for reading the data files will implement this file reader interface, and there'll be one method which they must implement, and we're defining that here. Read file as associative array. It'll take the file name as a argument, and it will return that associative array which I showed you earlier on. So if I look at my CSV file reader now, PHP Storm is shouting at me because I must implement that method. A lot of the time what I'll do before I start writing any code is I'll just add comments and sketch out the steps that I need to take in order to make this work. So I'm going to grab the rows from the file as arrays. I know I can do that with some of PHP's built-in CSV handling functionality. I'll separate the header, and then each part of the header will be a key which maps to a value. So this is how I'm going to do it. I'm going to use array map. This takes 2 arguments, the first one being a callback function and the second one being an array. So the callback function, I'll use PHP's inbuilt str_getCSV. The second part here converts the file contents to an array. Each line of that file will be an array element. So in our case, each one of those elements is going to be a string with commas in it. And what happens is array map will loop through each of those lines, pass the line into the str_getCSV function, which will split it into an array at the commas. We'll end up with an array containing 4 arrays. The first one will be the header, and I'm splitting that out here using array shift. Then we need to somehow get the header elements, or the header keys, and match them up with the values, and we're going to do that like this. So we'll loop through each of the rows. As you can see, I've established an empty items array, and what we're going to do is loop through each of the rows, and then we're going to kind of zip the elements in the header and the row up together so that they're matching, and we do that using this built-in PHP method called array combine. We'll pass the header in as the first argument and then the row as the second. So each element in the header 1, 2, 3 will match up with each element in the row 1, 2, 3. We add our newly combined array to the items array, and then all we need to do is return it, and that, believe it or not, should return us our array in the exact our content in the exact same array format as what we specified. So I'm going to require once the file reader interface, and we'll try this out. So I'm just going to stay in the same file outside of the class, obviously outside of the class curly braces. So file reader equals new CSV file reader, and then I'm just going to call the method read file as associative array, and it's the inventory.csv file that I'm reading. I'll store that in an items array, and I'll just print that out using print_r function. I'll add a PHP end of line, which is more of a habit than anything else. And then I just need to call this using PHP CSV file reader, and that looks exactly the same as the associative array that we said we were aiming for from the start. So good progress. We'll comment this out. What I want to do now is create a class which is going to use the CSV file reader, and so I'm going to create something called stock manager, and what this does, or what it will appear to do, is read a CSV file of data and then update a database with the information from that file. The main method in that class will be this one, update stock from file. It will take a file name as the first argument, and for the second argument I'm using a method called dependency injection to inject a CSV file reader into the update stock from file method. Now CSV file reader is now a dependency for this method, and when you inject a class or when you pass a class in as an argument to a method, you call it dependency injection. I'll not get too deep into it right now, but something like this CSV file reader, you refer to it as a service class because it performs a service for other classes, and you're usually more likely to inject it in through the constructor. I'll park that there though, and that's something we'll come back to at another time. For now we're doing it this way, and as you can see I'm using the CSV file reader read file as associative array method. I'm getting the return value of that and storing it in stock items, which will be an array, and I'm just going to loop through that, and then I'm pretending that I'm adding a record to the database. What I'm actually going to do is just print it out. I'll require once the CSV file reader.php file, and then once I've done that I'm going to need a file where I can go and play around with this stuff and print stuff out to the browser. So in the chapter 3 folder, as usual, I'm going to create a file called polymorphism.php, add some HTML. I'll rename the file title to polymorphism, opening and closing PHP tags. And so what do I need to do here? I'll require once the stock manager file, and then I'll create a new stock manager with stock manager equals new stock manager. And then what I want to do is call our method the update stock from file. So it takes two arguments, which the first one being the file name, and we're still using CSV, and then the second one we need a CSV file reader, so we'll also create one of those. CSV file reader equals new CSV file reader, and we required that in the stock manager file, so this should work. Let's go over to the browser and take this for a test drive. So localhost, I'm using port 8000, and then it's polymorphism.php. Okay, so the data looks good. I'm not sure about the formatting, so I've used a line break. Instead I'm just going to use a HTML break tag, and there we go, that's much better. I'll just bump the size up on this a bit so it's easy to read, and now we'll turn our attention to the JSON data. So what we want to be able to do is also read the JSON inventory file and update the database using that, but we can't really do it using what we've got currently because the CSV file reader, this is set up to handle CSV only, so we need another solution. We're going to need a JSON file reader, so let's create one of those. And again, I want this to be able to return me an array of data in exactly the same format as my CSV file reader. So I've called the file JSON file reader. This is also going to implement the file reader interface, so I'll require the file reader interface PHP file. Class JSON file reader implements file reader interface. As you can see, the squiggly red line is PHP Storm telling me that I must implement the read file as associative array method. And so exactly the same method name, except the internals of it will work differently. Like the CSV file reader, I'm going to sketch out using comments. Doing this kind of thing is quite good practice to get into because it just keeps you focused on the task in mind rather than trying to think as the code as you go along. You end up writing a lot more code than what you need to that way, I find. So I'm going to use the file get contents method. I'll pass in the file name, and that will take the contents of my file and read it into a string. So the file was in JSON format, which means I'll end up with a JSON string. And then in order to convert that to an associative array, I can just use PHP's JSON decode method. That will take the string as the first argument, and if I pass true boolean as a second, that will convert it to an associative array. And then all we need to do is return that items array, and it should return it in the exact same format as our CSV file reader. Let's test that theory now, and we'll stick in the same file like we did with the CSV file reader just to test this out. That's the code you need. We're just creating the class, calling the method. Let's go to the terminal and run this now. So PHP JSON file reader, and that looks exactly the same format, the same data as what we got back from our CSV file reader. So this is interesting. We now have two files, the JSON file reader and the CSV file reader, which both have the same method names. Let's go back to our polymorphism file and we'll try and use the JSON file reader in our stock manager in the same way that we did with the CSV file reader. So JSON file reader equals new JSON file reader, and instead of passing in the CSV file reader, I'm going to try and pass in the JSON file reader. So you probably know by now that this isn't going to work, but just go along with it for the time being. I'll require the JSON file reader. Let's move over to the browser and give it a refresh. Fatal error, uncaught type error. So argument 2 past the stock manager update stockman file must be an instance of CSV file reader. We've tried to pass in the JSON file reader. So I did this deliberately really to illustrate what happens when you don't use polymorphism, when you use concrete dependencies. Let's have a look at the method. So it's totally inflexible because we've injected CSV file reader, which means that we are stuck with only CSV file reader or a child of a CSV file reader, and it eliminates all other possibilities. Let's change that and make our code more flexible. So as you can see here, instead of injecting the CSV file reader, I'm injecting a file reader interface. I'm going to change all references to the name CSV file reader to file reader, which is more abstract. And as you recall, both the JSON file reader and the CSV file reader both implement this interface. So you might be thinking, where does polymorphism come into this? So thanks for your patience. Let's cover a bit of theory now. I'm going to knock up an interface file, or a file where I can play around and create classes. So I'll create an interface called random interface, and I'm going to create a couple of classes. Class A, and I'm just going to leave them as empty classes for the time being. Class B, and I'm going to make class B extend class A. So in PHP there is a way of checking if something is an instance of another class, or if an object is regarded to be an instance of a particular class. I've instantiated two objects here, one for class A and one for class B, and I'm just going to write a little conditional, and using the instance of, which checks if something's an instance of a particular class, I'm just going to check various scenarios. The first one is fairly straightforward. I'm checking if object A is an instance of class A. So I think we both know what the answer to this one will be, but we'll go and run it in the terminal anyway. So random interface, and it's true. Object A is an instance of class A. Let's try another one. As you can see, class B extends class A. So what do you think will be the outcome if we check this one? Is class B an instance of A? Over to the terminal, and it's true. Okay, so let's now check if object A is an instance of random interface. False. Let's make class A implement random interface. So class A implements random interface. What do you think? True. So this is getting interesting. If you think of the example we've been using, we've got a lot of power here. How about if we check if B is an instance of random interface? So B is a child of A. A implements random interface. What do you think? That's also true. Polymorphism is the ability of an object to take on many forms. So in PHP, an object that can pass more than one instance of test is considered to be polymorphic. So keep a note of that definition, because you'll definitely be asked it in an interview at some point. Let's change this require once, so we're now requiring the file reader interface, and we'll go over to our polymorphism file and we'll demonstrate that our code is polymorphic. So the first one we're going to check is we'll just leave it as it is with the CSV file reader being injected. Refresh. That works. We'll also prove that the update stock from file reader object can be a JSON file reader. So stock manager update stock from file, we're reading the inventory JSON file, and we're going to use the JSON file reader this time. Over to the browser, refresh. It works for both because the file reader object is able to take on many forms. So there might be parts of your code where you want to read CSV files, there might be parts of your code where you want to read JSON files. We're now equipped to be able to do either of those things. Our code's nice and loose. The file reader just has to implement the file reader interface, and that permits us to inject it into here, and then the underlying mechanism of how the file is read will change dependent on whether you're using JSON file reader, CSV file reader. This recording was about polymorphism, but we've touched on some dependency injection there. Don't worry about understanding everything, because we'll be covering dependency injection in a lot more detail later on in the course.